Hi, I'm Bob Tabor with LearnVisualStudio.net. In this lesson, I want to show you how to create simple helper methods which allow us to split up our Visual Basic code into multiple code blocks. So when I use the term method, I just want to be clear on this. At least at this point in our series of lessons, I'm using it synonymously with the term procedure that I used in earlier lessons. Methods are actually a special kind of procedure within Visual Basic, and I'm going to discuss why that is a little bit later. For now, I'm using the term helper method because, frankly, that's what it's normally referred to as, even though I'm demonstrating this concept using procedures within a module in Visual Basic. Alright, so hopefully I've satisfied the legalists out there. The bigger question at this point is, why would I ever want to split my code up into multiple methods? Well, let's start back at the beginning. Simply put, a method or procedure, a method is a block of code that's given a name so that you can execute that block of code from another block of code. It's one of the basic building blocks of building larger applications, and we'll look at some other building blocks like classes in a future video. So again, why would we ever want to split our code up into multiple methods? Well, there's actually many reasons why, but I think the primary one is that you want to, as a software developer, avoid writing the same code 2 or more times. You might find yourself writing a section of code, 2, 3, 5, 10 lines of code, and your first temptation may be to copy and paste that code all over your application where you need similar functionality. But whenever you have the feeling like that is something you're going to do, you should stop yourself dead in your tracks and realize that you really need that code a couple different places, and hey, I need it over here. Maybe I should create a method instead of just using copy and paste all over the place. So when you write a method and you call that method from each place that needs that same functionality, you're limiting the amount of code that you need to change should either a new requirement come up that affects that code, or if a bug were to appear in your code, you'd only need to change and look in one spot in your code to fix that bug. Okay, so that's the primary reason. There might be some others as well. Let's demonstrate these ideas by creating a new example. You can see that I've already taken a moment here and created a new console application called Helper Methods. Make sure you catch up by pausing the video. And I'm going to start by writing a new procedure, a new method called Super Secret Formula. And I'm going to make sure, first of all, to position the caret cursor within the code window in the proper spot. I don't want to position it inside of the body of submain. It's kind of a unit in and of itself. And I don't want to position it outside of the module because our method, our procedure, needs to live inside of it. So it needs to be kind of here on line 7. You can see where it comes after the end sub and before the end module. So what I'm going to do is this. Alright, so admittedly this isn't much of a super secret formula, but it'll suffice for illustrating a bigger point. So now, what if I wanted to use that code in the code block called Super Secret Formula? How would I actually reference that code from here in my submain? Well, let's do this. Alright, so let's run the application. I'm going to save all first. Let's run the application, and as you may have guessed, we'll simply see the hello world message. Now, how it accomplishes that is more interesting, obviously. What we're doing is referencing this helper method we created by using its name, invoking its name, and using the method invocation operators, the open and close parentheses. Now you might be wondering, why did we start with using the word function? How is function different than the word sub? They seem to be kind of siblings here inside of our module, and that's correct. The only difference between a sub and a function is that a sub will finish its work quietly, whereas a function will finish its work by returning some value. In this case, we're returning a literal string. That's what this as string part of our declaration of the method's signature means. So we're going to create a function and return a string. And then in the body, we actually use the return keyword to return the value. In this case, it just happens to be a literal string, but it could be something that's calculated or generated from a database or pulled from online or whatever the case might be. This is a very simple case. And then we retrieve the string returned from our super secret formula into a local variable called myValue, which we then print in a console window. Okay, that's all seems to be pretty simple. Before we leave this idea, though, we could create a second super secret formula, or better yet, maybe we should call it So how would we call this from our submain? Here we're creating a sub procedure, a method that we do not expect to return any value. It finishes its work quietly. In other words, it does not return something at the very end of its execution. Well, we would simply call it like this. You might even see in code the use of the call keyword, and it'll do essentially the same thing. But typically when I do it, I just use that. Okay, at any rate, just a side note there. Let's go ahead and comment all that out. In fact, let's go ahead and comment out this as well. And now, let's take a moment to talk about input parameters. So in this particular case, you can see that when we define the super secret formula, there were no input parameters. But what if we wanted to accept a name that we would then attach to hello world? So we might define it like this instead. And let's run the application. And you can see we get a slightly more interesting example, but only slightly. But again, it's the fundamentals behind the scenes, or behind the result rather, that is more important. We're passing in a value as an input parameter to our method. We've declared the method by val name as string. First of all, this is just like declaring a variable. We can then use that variable name throughout the body of our method, as we've done here in a string.format, and then using this replacement character that we talked about before to take the value of name and replace these curly brackets or braces inside of our literal string. But you might be wondering, well, what is the by val keyword? We're going to commit a whole video to talking about the difference between by val and by ref. So for at least this moment, let's just table that discussion and come back to it a little bit later. But we can also see that name is accepting, that our variable called name is accepting a string. You can also see that I have not declared this as string, but I probably should do that just to make sure that I'm returning the correct type. Otherwise, we'll be returning essentially as object, which is not what we want to do. And we talked about that earlier as well. But let's suppose that there are instances where we need to sometimes pass in a name and sometimes we don't want to pass in a name. How can we keep two versions of the same method that have a different signature, a different number of input arguments? Well, let's just start by removing the comments in front of the original super secret formula. And then let's change up our code here at the top too to demonstrate a second idea. In fact, let me comment that out as well. So notice when I'm typing in super secret formula that I get this listing that there are two different versions of super secret formula. When I use the open parenthesis, the first version accepts no input parameters. The second version accepts a name as an input parameter. This is called overloading a method. It gives us the ability to create two or more versions of the same method that extend its functionality. Instead of having to remember 10 different variations and 10 different names of super secret formula, I just have to remember the name super secret formula and then look at all the different variations, the different types of data that it will accept. So the same thing is true with WriteLine. Remember when we looked at this, we opened up the parentheses, there's 18 overloaded versions of the WriteLine method that each accept different data types. And we can see that some of them even accept multiples, like the ability to use a format string. So we could simplify what we've done a little bit earlier by using this overload as opposed to the one that we used down there in line 29, or some variation on it. So let's just do this and move ahead here. The other improvement that I've made is that instead of using two separate lines of code, one to call the formula and store its value, its return value, and then actually use the console.writeLine to print it, I'm doing it all in a single line of code. So whatever's returned from this, print it out to screen using the WriteLine. All right, let's see if it works. Great, it does. The key takeaway from this lesson, however, is the use of methods. We'll be using methods often in the coming videos for various purposes. You see them often used in the .NET framework, and I think it's important to understand, like we looked at with the console.writeLine, how did you have so many different overloaded versions of the same method? Well, this is how you declare them, by giving them a different method signature, all right? And so I just wanted to make sure that he had some exposure to this and explanation before we started to use methods throughout our examples. So as I said at the outset, a method is just one of the building blocks that we'll need. We'll also need to understand a little bit about classes, and you can think of classes as named blocks of code that are containers for our methods. And we'll talk about this at length in the next lesson. We'll see you there. Thank you.